you. So this is the session about instrumenting the mainframe, introduction to modern observability and OpenTelemetry. Doing this together with Chris, but Chris just had presentations for 2 hours, so I'm overtaking the session. But he's my partner in crime in preparing this and talking about observability and so on. And what I want actually, as part of the session, at the end of the session, I want from everybody a commitment to certify for OpenTelemetry and post this on LinkedIn. And I tell you throughout the session why. So let's get started. Let's give an introduction why, as part of the Open Mainframe project, we talk about OpenTelemetry. So the Open Mainframe project obviously is around open source for the mainframe, and on the other hand we have OpenTelemetry as an observability framework that aims to provide high quality telemetry data, so metrics, traces, logs, from any source to any target. And we have clients, customers for the mainframe that have an interest that OpenTelemetry is being supported for the platform. And as we started to onboard to this journey to support OpenTelemetry for the platform across different vendors, across different ISVs, we work together with the OpenTelemetry community, but at the same time we also work together with the Open Mainframe project. And then it was kind of like natural that we established a special interest group as part of the OpenTelemetry project to focus on the mainframe, but we did this together with the Open Mainframe project, so it's a cooperation, it's a co-active special interest group which goes as part of the OpenTelemetry project on one hand, but which is also part of the Open Mainframe project. We did this at the beginning of the last year, and I know he's not in the room, but I want to say thanks. So some of you know him. I want to say thanks to Aaron Young. He was one of the co-leads of this special interest group for OpenTelemetry before. He is now, or Greg Schimmer has now taken over at the beginning of the summer. Happy to have him on board. He is unfortunately not here in the room, but any chance when we have similar occasions to co-present with him will be welcome. So now I briefly explained who we are. We are the special interest group for OpenTelemetry on mainframe, and we have focus on semantic conventions. I will talk about what this is. We have focus on enabling OpenTelemetry for the platform, but to get our priorities right, we had at the beginning of the year a survey which we've done with the OpenTelemetry project. Maybe you have seen this on the website, either of the Open Mainframe project or the OpenTelemetry project. We have announced this. We got some feedback. Maybe it wasn't so much feedback like we wanted, so 45 people responded, so the results are not necessarily representative, but they gave an idea about what the community is thinking. And interestingly, the data also told us most of those who responded, they had a focus on mainframe. So they knew what the mainframe is about as a platform. And if we digest this all, we had 20 questions, 10 were more about who are the people that responded, and 10 questions really about interest so that we can prioritize then the work of the special interest group. And if we look at what came out of this, so even if we only got 45 responses, one point was we need to do more education about OpenTelemetry in the mainframe community. Now this might not necessarily apply to these people here in the room, because some of you, I know, they have background with OpenTelemetry, but maybe some of you not so much. Hence this session is specifically also to focus on OpenTelemetry, give an introduction, what it's about, but then also, that's why coming back to this point of commitment, make yourself a commitment and certify, and I will talk about that in a minute. And then there were a couple of other findings in this. So I will talk about what semantic conventions are in a couple of minutes, but obviously there is an ask for semantic conventions for system performance metrics, then also for job processing, databases and applications, so a metric requirement. Then OpenTelemetry is about SDKs, and we will also look at this in a couple of minutes. There's an ask for supporting at least the Java and the Python SDKs on COS. And then this reoccurring question also to having COBOL SDKs. I will talk about that also in a couple of minutes. And then at last, obviously also investigating of how can we make use of the OpenTelemetry collector. I will also introduce that one. But just to round this up, so this is kind of like the starting point for today's session. We had the survey, some takeaways, and now we want to engage with the community to get this done. OpenTelemetry is a project that is run by the Cloud Native Computing Foundation. It is the second most active project after Kubernetes currently in the community when you look at participation, contribution to the project, and the second most active one. And just recently also the community has been putting their a certification. First of all, a learning path, so getting started with OpenTelemetry. It's about 10 hours of course, and then at the end you can actually do a very brief exam just to get a certification that you have been taking place in this class. But also you can certify yourself as an associate for OpenTelemetry. And when I say commitment, my ask is do at least this class here, because then there's something to learn in this, right? Yeah, okay. We'll come back to this. And as we said, we want to introduce, or we want to get started with observability. And before I talk to the different specific definitions, let's look at a couple of scenarios. So we had this morning. Obviously, we had a couple of sessions today already about the topic, but as we are, focused on the mainframe, many of our customers are in the financial services industry. Let's take this example of a banking app. So the banking app, the way how they are today being developed and how they are deployed, they run on different landing zones. So they have services on different landing zones, and when I say landing zones, I mean they have services on public cloud environments being deployed. They have services on private cloud, so on-prem in the organization, in the enterprise deployed itself. And then they have services on the mainframe, so transaction processing systems, which actually ensure that the transaction takes place. And then, of course, there's also a flow of information back to the banking app on the front end when the transaction actually occurred. So there's in these modern applications, there's a complex architecture, often with microservices across these different landing zones, and then the mainframe at the back end. And what personas that are involved in the operations of this application require is to have visibility across all landing zones and across all the services of those applications. And this is then where observability comes in. So observability is really about getting, this is kind of like the definition that I usually went with, this is about, observability is about getting actionable insight into a system, complex system, to be able to address issues either proactively or reactively. Now, my definition might be a bad definition, that's why there are better definitions. And the one that I really like is the one from the Cloud Native Computing Foundation, and this is also where the circle closes with the OpenTelemetry project yet, because they are OpenTelemetry under the umbrella of CNCF. And obviously also CNCF, large focus on observability. For some time they also had a work group specifically dedicated to observability. Also there's a white paper out there. If you research this on their website, you will find a white paper what their understanding of observability is. But now let's look at the CNCF definition of observability. And the way they describe this is observability is a system property that defines the degree to which the system can generate actionable insight. And what I really like about this definition is that observability is made an attribute or a property of the system itself. So what that means is the responsibility to be observable, to be best observable, is moved into the system. And why do I say it's moved into the system? Because previously, for many years, when we had application performance management tools, they have been bringing actually the instrumentation for the system, and there was also kind of like this competition. Those APM products, application performance management products, that had the best instrumentation for those technologies, they already had a benefit in the market. But with this definition here, now this responsibility goes or is being assigned to the system itself, and it's not anymore about a specific tool or product that should be bringing the instrumentation so that the particular technology is best observable. And this asks, obviously, that then these systems, these technologies are able to emit signals, and again signals, metrics, traces, logs, sometimes also profiles, so that these systems are best observable. And why do we do this? Because users need to understand or should be able to understand the system's state based on these signals that are being emitted. And then obviously we should be able to take actions on those. So this is the kind of like the straightforward definition of observability. Now the world would be too easy if there would be only an observability definition 1.0. So there's a second one, observability 2.0. And you also can find this on the CNCF blog. And the term observability 2.0 came up a couple of years ago. But it really focuses more on actually bringing these different signal types together. So integrating metrics, logs, traces, and also here especially calls out events. And then on this basis, and also in real time, be able then to diagnose how a system is behaving and address issues so that you can actually resolve them, and also be able to do this in complex systems like this banking app that I was describing. And this is also where we'll see this later, but this integration of these different signal types, this is also an aspect that OpenTelemetry will address. Now, let's take a little bit more details on these definitions. As I mentioned, there's this blog out there at the CNCF website, and there's a couple of more aspects in terms of observability 2.0, which are of interest here, and let's briefly look at them. If we look at the capabilities that observability can provide or should provide, so in terms of data handling, observability 2.0 is really about bringing these signals together, but also doing this in a unified platform. And this aspect of unified platform is important because then you can easily correlate these different signals because they are in one place. You can actually also, sometimes there's this discussion around structured events, and these structured events, they can then again being linked with those signals, they can have actually large complexity based on what is being observed from those systems and those relationships that you can have, for instance, in your microservices environment, and being able to navigate this data from one source. This is important in order then to address these other capabilities, like problem detection. Obviously, we are moving in a world where AI has a large role, but also now with agentic AI, it becomes even more important that systems in an automated way can actually consume this data, can understand relationships in this data, and then draw conclusions from this, so do reasoning, and then decide on certain actions that need to be taken, and for instance, to take an action in response to either a rising or existing problem. Then this aspect of focus on context. So traditionally, this was very much about infrastructure and applications and these type of signals. But now, with Observability 2.0, there's also this aspect of business metrics. So how is my application behaving in terms of my business goals? Is this application still running so that I can meet the requirements that my business has to this application? Am I still serving my customers? And am I still in an SLO, so the service level objective, that I maybe have agreed with my customers or that I have defined for my application, so that I can see I'm running fine, the application is running reliable, there's no problem building up, and there's no issue. Vice versa, if I only have, let's say, infrastructure metrics, I may see that the service is up, but I may not recognize that a particular service is responding slow, or that there's a particular problem for a specific set of users because they are in a specific location. So taking in more this business perspective and then being able to break this down into what are the contributing factors if there's a problem with these business metrics, that's key here as well. And then at last, this is more the obvious thing, but scalability and adaptability, businesses are changing quickly. So observability solutions need to be able to respond to this quickly. And this is the typical scenario, Black Friday. Of course, you have an increasing business, but this is only just one example. So you may have changes in the demand to your application, and you want to be able to respond to this. So you need to be able to scale and easily adapt to new requirements that come in from an application perspective. This takes us to a discussion around what are actually capabilities of modern observability, and specifically also in the context of AI and machine learning. And there's 4 domains or four capabilities that you will find that more and more play a role in this space. So there's anomaly detection. Can you detect that from a normal state, if there is a situation building up, that there is a problem? So is the normal actually somehow impacted by an issue? And anomaly detection is a technology in the meantime that you find in many tools, many products. But anomaly detection essentially helps you to identify a situation if your application either has a problem or if a problem is building up. Root cause analysis, in the old days, you went through the logs, you analyzed logs. Maybe you had to call somebody to get you the other logs. You need to be able to correlate logs of different components. That was really the hard part. Maybe then we got additional tooling. We got traces and metrics and logs, maybe even correlated, but still it's, you need to go between different panels. And if you think about root cause analysis, that is actually more and more becoming a capability that is assisted by AI. So there are already solutions out there that help you to understand the context of a particular problem, and on the basis of this context then make suggestions what the actual root cause of a given situation is, and will help you to address the problem. Obviously in this area, we will not talk about this in this session here, but if you research root cause analysis, there are commercial tools. There is also in the open source world certain articles that describe this. Model context protocol server, MCP servers, and agentic solutions start to play a role in this to just help you to gather the context, identify potential issues or root causes of these issues, and then help you to resolve this. Then predictive analysis. This is an area, if you put this into context, what I said earlier about business metrics, for instance. Can I predict a certain situation that is building up so that my application will be impacted in the future? And can I prevent this situation early so that my customers are not impacted? So can I resolve a situation that is building up, address this early based on prediction, and then resolve the issue? Predictive analysis, This is something that is probably in the early stages. And then at last, automated remediation, kind of like in this context of going more and more to autonomously operated systems. If there's a problem, and I went through these different steps here, detecting the situation, being able to analyze the root cause, can I automatically derive a remediation action, and can I as well then execute this with trust? And this is one of these challenges in this space. If I have a certain error situation or a problem situation, can I trust an AI or ML solution to take an action on behalf of the person, behalf of the human, to resolve the issue? And in early stages, we surely will see human-assisted activities there, but recommendations, so automated, but recommendations how to remediate. And as trust builds up, then more and more we will get into this area of automated remediation, obviously. So this is kind of like these 4 areas: anomaly detection, root cause analysis, predictive analysis, and automated remediation, that in the observability space you will find more and more as criteria to decide if an observability solution is complete, is a good solution to be used. Now let's make the link to OpenTelemetry. We spoke about the different signal types. We spoke about the definition of observability 2.0. There's this one sentence out there, also a blog here, storing all of your observability signals in one place matters. And obviously, Ted Young is one of the co-founders of OpenTelemetry. He put that already at some point into one sentence, calling it the 3 strands that make up a braid. I actually had to look up what a braid is in English language, but essentially it describes to weave together these different signal types, metrics, traces, logs, into one form and use them all together to be able to draw conclusions based on this data. And this is then where OpenTelemetry comes in. OpenTelemetry's mission, I think I said this at the beginning, but it's really about enabling an effective observability by providing high quality telemetry data, making this available from any source to any target, making it portable, and making it consumable. And if we talk about OpenTelemetry, then let's look at OpenTelemetry from what the community is doing. So, as I said, OpenTelemetry, a framework for observability, and the community has been working on specification and implementation. And if you look at the specification, then there's an OpenTelemetry protocol. And the OpenTelemetry protocol describes of how the telemetry data is being encoded when it's being sent over the wire. There are definitions being made of how this encoding is done via gRPC and HTTP. And the OpenTelemetry protocol is really this layer that unifies this transport of the telemetry data between the sources and the target. And I say unify because most of the observability vendors, observability tools, in the meantime, they support the OpenTelemetry protocol, and it's really the standard of how you ingest telemetry data into any of those backends. Now, as I talked about specifications, there's also API specifications. These API specifications are there to describe of how you collect telemetry data at the source within your program, in your application, for instance. And then also API specification, for instance, of how you would export the data from your application. And then there are semantic conventions. And semantic conventions, they give us a common language for the telemetry that is being exported by OpenTelemetry. So this semantic conventions give us a definition for instance, common resource or entity names, common metric names, common attributes, And by having this common language, also the data that would be then exported through OpenTelemetry becomes portable, because the consumer that adheres to the semantic conventions will easily understand if a certain metric has a certain name, then he can expect, or this tool can expect, that it has a certain semantic and a certain meaning, and then can be consumed accordingly. If we look at the implementation side, then we have SDKs for these APIs, and there are currently 11 SDKs out there. We will look later on at this, but essentially, if you think about Java, if you think about Python, Go, I don't know what kind of languages you are using in your environment, but you will probably on the distributed side find an OpenTelemetry SDK. If you think about the mainframe specific languages, then there's obviously work to be done. We will talk about that in a couple of minutes. There's another component that we want to talk about when we talk about implementation, and this is the OpenTelemetry collector. Just very briefly here on this slide, OpenTelemetry collector allows you to define telemetry pipelines, and the telemetry pipelines are a way to, in a descriptive way, describe of how this telemetry data is to be received, to be processed, and then to be exported. So it's a component that is sitting between your source and your target, and allows you to do processing, modification of the telemetry data. Now, just for completeness, we spoke about the different signal types already. So there are traces, and traces give you a way, we also sometimes talk about distributed tracing, give you a way to follow how a request is being processed by the different services of an application. I spoke about this banking application, which has services on public cloud, private cloud on the mainframe side, so many services involved. But also, if a specific user request is being processed by a system, it can actually take different passes. We have high availability, we have scalability, so a request may hit a specific container for processing, may hit a specific service for processing, and we want to see this. So the trace as a way is a way to understand this path of how the request is traveling through the system. Then obviously metrics as a way of measurement to express either the state of the system in form of a measurement, but also of an application. This can be CPU utilization, but could be also number of calls of APIs, as we had it this morning in the discussion. And then logs as a textual way of representing certain events that happen in the application or in the system. And then at last, we have profiles, and profiles are a way to describe where consumption, resource consumption occurs within the code of my application. Profiles not so often used, also the last of the signal types that the community has been working on the specification, but obviously of high value if you have a certain situation in the system and really need to understand where the resource consumption is coming from. So we spoke about bringing these different signal types together, and this is where the OpenTelemetry project has been also looking in the data model for these different signal types of how to realize correlation between those. And just as an example, so you can correlate logs, for instance, with traces. So within the specification for the logs, you will find the information about the trace ID and about the span ID. Similar, you can actually correlate also metrics with traces. You can have an association of a particular metric as an exemplar with a particular trace, and also profiles can be associated. So already built into the data model of OpenTelemetry, we have ways to correlate those signals. And now that this is already there, there is now a development, this is currently ongoing by the community, to move from resource definitions to entities. So what are resources? Just to briefly describe this again. If I look at these different signal types, originally a resource was describing where the telemetry is being generated from. That can be an application, but this can be also a host, for instance. And we had a flat definition of these resources originally. So there was, for instance, a set of attributes, service name, service attributes that would identify this resource. Now, community is moving towards what is called entities as an extension to the current resource definition. But the good thing about entities is they can have a defined type. They can also have an identity by a set of uniquely identifying attributes. And then these entities can have relationships between each other. And this is really important because then we can express, and this is not yet in the semantic conventions specification, but then we can express things like a virtual machine is running on a particular host, for instance. So, and when we think now about concepts that we have on the mainframe, think about the virtualization concepts that we have on the mainframe, then we need also to look at how we express a set of LPARs is running on a particular CAC. On these LPAR, there's again a hypervisor being deployed, and on this hypervisor again I have a set of virtual machines running. And this is a typical infrastructure that we would have on the mainframe side, yes?
Can I ask you, is there any talk around expanding or reusing this model on CMDB?
I haven't heard any relationship to CMDB yet, but it's somehow, this is the thing, right? So we have already such type of topologies in various definitions today, right? And what would be good if the community, they put forward then a definition for virtualization that this works together with topology definitions like you would, for instance, have in the CMDB or in other places, right? Yeah. Okay, that takes us to semantic conventions and with entities. Also, the way of how we define semantic conventions has been changing. Previously, we had just, like I said, a flat model. Obviously, in these semantic conventions, and they are described as a model, and in this model, just here as a pre-orientation, I can describe these. Previously, I described resources. Now I describe entities. I can describe spans, what kind of attributes are in these spans. I can describe metrics and so on. And then there's a compiling step that translates this definition, this model definition, into documentation, and this is in the end published at the OpenTelemetry website. And with this moving towards entity, in addition to the attribute registry, which we had previously, and anything, if you want to introduce, certain attribute on a span, you first need to register this in the attribute registry. Now also there's an entity registry, and this entity registry will then also serve as, providing anything that the community is defining as an entity that can emit telemetry. So just to note, an entity always emits telemetry. From a special interest group perspective, obviously over time we want to do definitions to represent the mainframe as part of the semantic conventions. We've done first steps. We need to do more in this. We're on the way for the initial spans as part of distributed tracing. We had initial discussions on this entity model that I had earlier on the screen. And surely semantic convention is one of the key areas to focus on for the special interest. Also, as we have seen, system performance metrics. And again, this will help if you look at the mission. If you have semantic conventions, this will also help to make this data portable, at least for the lower layers of the platform. This will be helpful. And as well, if we talk about basic concepts of the platform, then we want to have this represented. Surely not all metrics that are there in the vendor space will be represented through semantic convention. But as I said, basic concepts, that definitely makes sense. Now let's make a conceptual change. Let's talk about applications. So, and let's start from a Java application. If I want to start with OpenTelemetry instrumentation and I have a Java application, then The community is providing SDKs, as I said, but they also provide Java agent or a Java agent that allows you to instrument your application with no code change or with zero code change. So all what you need to do is essentially when you start your application, specify the Java agent for OpenTelemetry. And what this will do is it will capture incoming requests through HTTP. It will also provide an instrumentation for JDBC. And then you get already some initial information about how your application is behaving. You can extend this instrumentation with code-based instrumentation using the SDK and the APIs that are provided there then to, for instance, add additional spans or add additional application metrics so that your instrumentation for the application becomes more complete. There's one interesting aspect for zero code instrumentation, and I think this was just recently published while the community has been already working on this for a while, which is OpenTelemetry eBPF instrumentation, specifically of interest on the Linux side, as this is being built into the kernel. And eBPF, obviously, Berkeley packet filter originally, but having multiple functions in the way of managing applications on the Linux platform. Also, you find this in the Kubernetes environment. There's also a whole ecosystem of tools around eBPF. If you think about Cilium, probably don't get the name right, but this is another project under the CNCF. And also providing actually information about application instrumentation. And this is now being used by the OpenTelemetry project. This works. I presume we haven't tested this, but there is eBPF support on the Linux and C side. So would be one of these things to be done to test it on the Linux side. And on the COS side, we don't have something like eBPF. There was once, we had the Discord channel up earlier in one of the sessions. I think there was once a question if eBPF is required for the COS platform. Maybe it comes back if there's a need from an OTel perspective in future. I said 11 languages. How does it look like? So there's this set of 11 languages. Pictures a little bit better on the Linux side for S390X because we are in an environment where obviously on the x86 platform the development occurs. We validated some of these SDKs and obviously Java and Python, they work very well. For C++, there are some instructions out there. Point is, there is no community support there yet. And community support would mean that you go to the website, you can read that the platform is actually supported from the SDK perspective. I will come back to that aspect. On the COS side, it's a little bit different. There's more work to be done. We know that Java works well, also with the work that we have been doing for native distributed tracing. Recently somebody told me Python may actually also look good. But again, this is validation work, and this is where also the community is asked to validate this. Let's talk about COBOL and the mainframe specific languages. Obviously, feedback from the survey, also from other sources. I spoke to our DE for languages on the platform, distinguished engineer DE, and our conclusion was actually this needs feedback from the users, this needs feedback from the community, from the clients. And probably from an IBM point of view, we will start something like a sponsor user program to interview customers who really ask for this, to get a better understanding what the requirement here is, and then need to derive of how to do that best so that you always have to keep in mind changing these programs. This will be invasive. Surely we would have to provide APIs or interfaces, but is there maybe a smarter way to get also some of this telemetry data in a no-code way? Very briefly, distributed tracing. We had this session this morning about distributed tracing is a no-code instrumentation for MQ, KIX, IMS, and DB2. And it gives you span information, and you can actually, once once configured on these newer releases or current releases of these products, you can get a distributed trace. I want to wrap up this session with talking about the OpenTelemetry collector. And as I said, the OpenTelemetry collector is about pipelines. And when we think about telemetry pipelines, in telemetry pipelines you describe the steps of how you receive the data, how you process the data, and how you export this. And you can, for instance, filter for certain attributes or for certain metric points, data points, and skip them. You may also add or remove attributes. You may have some resource detection, and you may then use this information that you get from the resource detection and inject this into your telemetry. And then you may use the batch processor as a more effective way of sending out the telemetry data, because the data is essentially put into packets that are then all sent out together, having less impact on your network, and then you can send out through telemetry protocol, but also through specific protocols like Prometheus. And if you look at this, very flexible, there's a whole ecosystem around plugins for the collector. Obviously, you have plugins for receivers and exporters for proprietary protocols. You define your pipelines, it's probably better visible from this slide here. You define your pipelines based on the signal type, and then you define the steps of how you want to process the data. It's probably hard to read, but we have here an example where we take the resource detection and then add attributes using the transform processor to this matrix, and then we export the data over to the target. The OpenTelemetry collector is also available for Kubernetes environments. So you can run the collector there, or the collector which comes as the OpenTelemetry operator. You can run this either for then these no-code or auto instrumentation scenarios, and you can run it also in a regular deployment. You speak there about gateway deployments, and these gateway deployments essentially allow you then to take telemetry data from different sources, define your pipelines, and push this through. If we look at what is available for the platform, we have the collector. This was work that we also did as part of the SIG in the early days. We have supported as tier 3. Tier 3 means it's built, but it's not part of the CI pipeline of the community, so it's not unit tested. What we currently do is we are working to integrate a GitHub action runner for Linux on C with the community, which then also will allow us to run unit tests as part of the CI pipeline. And once we have this configuration done, then the next step is essentially change these action workflows for the CI pipeline. But then we can also evaluate the collector support to tier 2. It's also something that is being asked from the community, interestingly. So one of the topics that we are currently working on. Before I wrap up completely, any questions on OpenTelemetry or observability?
Just a little bit clarification on the no-code part.
Yeah.
If I have a Java application running in a WebSphere,
Yeah.
let's say Liberty, and that is deployed in Kix, can I instrument it as of today using?
So if this is Liberty in Kix, then you can use the support in Kix 6.3. And if it's not Liberty in Kix, then there's already microprofile or the Java agent support there. So you are covered on this side. It's probably reasonable to point out from a Liberty in Kix perspective, there are a couple of scenarios that we are still looking at, also to enhance this further. I said this in the other session. We delivered an MVP in 3Q this year, and we are continuing our development to close on some of this functionality, but Liberty in Kix is supported.
Thank you.
Other questions? Okay, then agentic AI and OpenTelemetry, just very briefly. Now that we have MCP servers, so model context protocol servers, is OpenTelemetry still necessary? So why this question? because it's actually two ways of how you access your data or can access your data. OpenTelemetry is a push, so always from the system towards a backend. MCP is obviously a pull. There are scenarios where you would also pull telemetry data from a system, but if you think about observability, telemetry or OpenTelemetry should always be used to feed data into an observability backend. And an MCP server that specifically is designed for observability use cases should sit on top of an observability backend. So long story short, yes, you will need both also in future. Just for completeness, there are semantic conventions also for generative AI systems, and also frameworks like VLM, Traceloop. They are supporting OpenTelemetry. So as you enter this space of working with agentic AI, OpenTelemetry has a role, for instance, to be able to follow of how inferences are being made, and then also in terms of acting on observability data. We spoke earlier about these different use cases, capabilities that rely on AI and ML. That should happen in your observability backend, so OpenTelemetry should be feeding in there. This leads me to the conclusion. So get your OpenTelemetry badge, make yourself a commitment to do this, and post this on LinkedIn under the hashtag OpenTelemetry. This is about visibility of the Mainframe community and the OpenTelemetry community. So it will be a good thing if you do this. And then at last, if you want to engage, obviously there's various ways, but enabling, for instance, community support for Java, Python, maybe work with us on the COBOL implementation. This will be, things that are very much welcome. We didn't even talk about the OpenTelemetry demo. We know that it's partially running on Linux and C, but making this once working completely on Linux and C, this would be the best showcase that we have as a community running this platform. And obviously next year, GS UK, I have to say, maybe we can work together to do an OpenTelemetry lab on COS all together and have students, clients running through this and get a mainframe specific badge. Okay. I think you heard about IBMC Day in the meantime, coming up on the 12th. Also, we are looking there for a soundtrack. And then at last, please provide your feedback. Thanks very much.